Hi, I'm Guo Cheng Guang, secondary one from NS High School. Right out here, we're at our organic chemistry, chapter 1, classification of different things or organic compounds. Well, right now here, although what we're trying to solve are not actually for organic compounds, you'll say them as inorganic compounds. But we're just using these just to show us how we can find, for example, we can use these methods to find charges, to find currents, mass, time, with actually pretty much anything else. For example, heat energy. Then as it goes on, heat energy, you can have specific heat capacity, and then, for example, enthalpy, entropy, and also there's one more, chemical potential, and there may be other things. So those are just some of the things that we might just need to find. So right now here, we're just starting with the first, the basics, with mass, time, current, or charge. So those are just what we're having right now. For example, this example here, we have to calculate the time required to deposit 7 grams of silver from a solution of, you see that, AgNO3. That is silver nitrate. And then with a current of 4 ampere. Well, in this part, the compound that we're having here is silver nitrate. Well, if you have seen silver nitrate before, silver nitrate is mostly transparent, except if you mix tissue in water, something like that. Well, you can say there are white things floating about in that solution, if you have seen them before. So over here, we need to calculate the time, and we are given the mass and the current. So given mass and current, let's just write that down first. So the mass that we have here is 7 grams, while the current is 4 ampere. Okay, these things we have first. Another thing that we need to know is that equation, whereas when we change AgNO3, so what we change this into. So from this part, it is changed into Ag plus, then you add NO3 minus. So this is the part that you have. This is what you need. Then that means Ag plus, you need to add one of these electrons in order to get Ag. So this is what you need. That means you need 1 electron. So here you have mass and the current. Well, what can we get from these parts? The mass. So the mass, that means we could use the mass to find number of moles of, well, here Ag, just know that this is silver. So number of moles of Ag, you have 7 over, while using this mass here, over, that means you have to over the atomic mass for silver. So that means 107, well, for this part, you'll have to be like this, 107.87. Well, during tests, they may allow you to refer to the periodic table, some of the tests. So here, this is for moles. Okay, so you have found number of moles for silver. Then after that, you can find the number of electron, number of moles of electron. But if you have realized that one of this silver, you just need one electron. So that means actually it's just the same. But just for step by step, you go step by step like this. Moles of silver, moles of electron, then number of electron. Well, you can say like number of electrons needed to be supplied. There are different ways of writing this. So if you write number of electrons needed, let's take a look. That means we have to times the Avogadro's number to this part. And you get 7 over 107.87. Then you have to times 6 times 10 to the power of 23. Just because 6 times 10 to the power of 23 is like what we're using for now. This is what we're using for Avogadro's number. So then here it is number of electron. Okay, so you have already found the number of electrons that you will need. That means the next part is that you need to find like how much coulombs you need. So that will be for the charge. So the charge that you will need here. So from here you have to times another thing. So you times so from here we're just going to use this number. Okay, so the charge here you have to times 1.6 times 10 to the power of negative 19. So for the charge, the unit that we're using is coulomb. So then according to what we are needing to find, like I in this part will be Q over T. So this is what we're using right now. So what you have found, okay, you're given the current, yes, you're given this current, you have found the charge, when you find the time. So time, that means there will be charge over current. So the time taken, so charge over current. Well, this will be what you get. So this workings like might seem like very complicated. So in tests, they'll normally allow you to use calculator to calculate for this part. Okay, so from this part, what you get is 1557.43. Well, time taken, so this will use seconds. Well, unless they ask you for other units, like for example minutes or hours or some other units. So if not, you're just going to use seconds for this part. So this is what we'll have so far. So actually, if you just understand the question and you know how to step by step find it, it's actually quite simple. But of course, first of all, you have to know what the question is asking for and the whole process. So in this lesson, I hope that you are clear so far. Well, let me just tell you again. So you're given mass and current, and definitely you have to know for their equation and ionize this process. So first of all, you change from this mass, you go and get the number of moles. Well, just by using the mass given and the atomic mass unit, or yeah, you can say like atomic mass. Then after that, you find electrons, number of moles of electrons from this part that you have. So then you get, well, actually the same number. Then after that, you times the Avogadro's number to find number of electrons needed. Then you times, like, just make a conversion between number of electrons and the charge. Then you just use this part to find the time taken. So that's actually just the whole process. So we'll see you in the next lesson. So if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.